Bonding Part 4. Example 1. Predict the shape of silicon hydride SiH4 using the VSEPR theory. The electron configuration of silicon illustrates that silicon is an sp3 hybrid. It has 4 electrons in its outer shell, 4 valence electrons, 4 dots. Hydrogen has 1 valence electron in its outer shell, 1 dot. The first step is to determine the central atom. Select the atom in the formula with the lowest numbered subscript. In this example, SiH4 silicon hydride, there is only 1 atom of silicon, so start with the dot notation of silicon. Silicon has 4 electrons available for bonding and no lone pairs. 1, 2, 3, 4 available for bonding. Surround the silicon atom with the electrons from the hydrogen atoms, making pairs of electrons. The shape of SiH4, silicon hydride, is tetrahedral, like CH4, methane. If you look, CH4 has no lone pairs and 4 bonding pairs, just like SiH4 has no lone pairs and 4 bonding pairs. Example 1 continued. The shape of silicon hydride is tetrahedral, like CH4. Examining the periodic table, elements in a group form comparable compounds with similar geometric structures. If you look at the periodic table, carbon and silicon are in the same group. They have 4 electrons in their outer shell. They make tetrahedral compounds with hydrogen. Example 2. Predict the shape of H2S, hydrogen sulfide, using the VSEPR theory. The electron configuration of sulfur shows that sulfur has 6 electrons in its outer shell, 6 dots, 6 valence electrons. Hydrogen has 1. The first step is to determine the central atom. Select the atom in the formula with the lowest numbered subscript. In this example, H2S, hydrogen sulfide, there is only 1 atom of sulfur, so start with the dot notation of sulfur. Sulfur has 2 electrons available for bonding, this one, and 2 lone pairs, this one and this one. Surround the sulfur atom with the electrons from the hydrogen atoms, making pairs of electrons. The shape of H2S is bent like water, H2O. If you look at water, 2 lone pairs and 2 bonding pairs. Looks exactly like H2S, bent molecule. Example 2 continued. The shape of H2S is bent like water, H2O. Examining the periodic table, elements in a group form comparable compounds with similar geometric structures. So if we look, oxygen and sulfur have 6 electrons in their outer shell, 6 valence electrons, 6 dots. They make the same kind of compounds with similar structures.